Hello student, welcome to our physics discussion, that is physics in a smart way. In our last class, we were talking of Newton's first law. Now, those videos are over, and we have to proceed. Let us proceed to the Newton's second law. And that says, if somebody refers to the so-called initiative rule, that says that the net external force as described in the first law is proportional with the rate of change of momentum. It's proportional with the rate of change of momentum. Of course, at this time, you must be knowing what momentum is. Momentum is a vector quantity, that is the product of mass and velocity. Mass and velocity, multiply mass with the velocity. Because velocity is a vector, so due to that momentum gets in direction, and the value is to be determined by the product result of mass and velocity. Okay. So coming back, as per NCERT, they say that the net external force is proportional with the rate of change of momentum. With the rate of change of momentum, as you have mentioned. So next step, that implies the net external force will be equal to a proportionality constant into dp by dt. And then it claims that the so-called old masters like Newton and all that, they did select the value of the proportionality constant very judiciously, and they make the value of the proportionality constant to be 1, and all those things. But my point is, why go to all those details? Why we should not directly say that net external force equal to rate of change of momentum straight away? Because either you say that net external force acting on a body is proportional to rate of change of momentum, or you may say that net external force is equal to the rate of change of momentum. Both are not original statements given by Newton. You may refer to his classical work on mechanics. Okay, Newton did mention things like mass, acceleration, and force, and all those things. The momentum was not his original statement. So you may write like this, there is hardly any difference once you make k equal to 1. But thing is that when it is not required, why you go into all those hassles that putting deliberately drawing a proportionality constant and then reducing the value of proportionality constant equal to 1, all those things. Thereby, to me it seems we are going away from the core issue. So thereby we consider the second way, that net external force equal to rate of change of momentum. Let me remove the thing that was there because we need more space to make our mathematical moves. Okay. So once you say F net equal to this much, here furthermore, I just refer the net external force, I add F only because we don't have got patience and space to write all those things. So that says that F equal to, and when I say F, here it is to mean that is an external net force. Rate of change of momentum, if we say rate of change of momentum, rate of change of momentum, we know in place of momentum, we can write mass and velocity by dt. Somehow, by this time, you are aware of somehow the basic calculus those we require for our study of physical sciences. I think I'll be uploading 1 or 2 videos in support of those derivative and integration. Just the basic ideas so that it will be helping you. But as it is presumed that you know all those basics, So derivative of within bracket the product of mass and velocity by dt. So this can be written as mass into derivative of the velocity. Type of bracket doesn't matter. You may put a square bracket or cursive one, doesn't matter. V into dm by dt. If somebody follows the rules of the derivative, then our F net or net external force is to be the so-called expression that is like this. The complete realization of this expression and all those things will be coming with later, because at present we cannot go into all those details of this and the momentum, all those things specifically. So our basic job is to get strong on the Newton's law. So thereby we know on the right hand side there are two terms, m into d by dt plus v into dm by dt. So that can be expressed as m into dp by dt. We know that is nothing but acceleration rate of change of velocity plus v into dm by dt. Okay, the second term is bit meaningful. That will become bit meaningful when the masses are variable. But here we put in a condition where at present that condition is there in 90% of our questions at present. If we consider the mass as constants, means the mass is constant, mass doesn't change. Let us say we got a trolley has got sand upon it. You just cover a polythene on the trolley and just you got sand over it, and you apply a force. And the trolley is starting to move. When the trolley is moving, you may put in more sand, or maybe some sand is slipping out. So those are known as variable mass systems. Initially, we are not able to deal with them right now. But if our case is not that, or let us say maybe I am having a trolley and trolley is having a large plastic bucket on it, it is raining heavily, I apply a force on the trolley is moving on a horizontal surface, at the same time due to steady rain that is collecting rainwater. So those are variable mass systems, and those can be, some of them can be quite interesting things. At the same time, rocket propulsion, motion of the aeroplane, how a jet engine acts, and all those things are quite interesting. But at present, we dissuade ourselves from that. Our job is something different, to have a firm hold on the Newton's law. If mass is constant, if mass is constant, then the second part that is there in the Newton's law, rate of change of mass is zero, because mass is not changing. Derivative of constant is zero. So thereby, because the second part vanishes, so our thing will be that external net force will be the first part of RHS only, mass with acceleration. So that will be our rule or formula for majority of the cases, except those variable mass systems, which we will deal with them later, and we shall mention them. Sufficient warning will be given to you. So for a constant mass system, Newton's second law is very simple. If somebody expresses it mathematically, symbolically, that external force equal to the product of mass and acceleration. Okay, that is all about Newton's second law. We shall discuss the Newton's third law in our next video. So thank you for your kind ear, and we shall